Good day everyone! Our topic for Module 8 is T-distribution and confidence interval. And we have objectives. Number 1, illustrate the T-distribution and enumerate its properties. Number 2, differentiate the T-distribution and Z-distribution. Number 3, identify the length of the confidence interval given the sample mean and margin of error. Our lesson will be run only in T-distribution. This is also known as the student's T-test. Why student? This is the pen name used by its proponent, and that is William Seeley Gossett in 1908. He developed T-distribution in 1908. Gossett was working in Guinness Brewery. He is a mathematician and he was studying the difference between barley yield. It was not financially practical for the company to have a lot of samples at time. And this is the reason behind the birth of T-distribution. T-test is used when sample size is a small and or when the population variance is unknown and the observations come from a normally distributed population. T-distribution is based on the sample standard deviation, S. And the formula for this is T is equal to sample mean minus mu all over sample standard deviation divided by the square root of n. And here are the property of T-distribution. Number 1, the T-distribution is bell-shaped and symmetric about the mean. Number 2, the mean, median, and mode of the T-distribution are equal to 0. Number 3, the total area under a T-curve is 1 or 100%. Number 4, the tails are asymptotic to the horizontal axis. These four properties are quite familiar, right? These are the same properties of Z-distribution. Then what is the difference between Z-distribution and T-distribution? Let me show it. Here is a Z-distribution. And this one is a T-distribution. You will notice that a T-distribution is shorter and has fatter tails. Shorter meaning they have lower peak. And why fatter? Because T-distribution have a greater chance for a extreme values than normal distribution. Why? Because T-distribution is based on a sample size. That is why the variability is greater than the normal distribution. Another property, there is a different T-distribution for each sample size. T-distribution is a family of curves, each determined by a parameter called the degrees of freedom. The degrees of freedom is the number of values that are free to vary in a data set. Let me explain this further. For instance, we want a mean of 100 and we have 4 slots to fill. We are free to write any number on the first slot. Let us say we put 98 here. And on the second slot, we are also free to write any number. Let us say we will write 99 here. We are also free on the third slot. And let's say I will put 101 here. Now, Can we put any number in the fourth slot and still have a mean of 100? No. The only number that we can put here is 102. Adding all these 4 numbers and dividing by 4 will give me a mean of 100. So, from the first slot that we have, 3 slots are free to vary. Number 7. As the degrees of freedom increases, the 3 distribution approach the normal distribution. So, let's have a normal distribution. This one is a T-distribution with degrees of freedom equal to 3. This one is a T-distribution with degrees of freedom equal to 5. And this one is a T-distribution with degrees of freedom equal to 10. So when the degrees of freedom is equal to 30, then the T-distribution almost matches the Z-distribution. Number 8. The variance is always greater than 1. It is equal to the degrees of freedom divided by the degrees of freedom minus 2. As the degrees of freedom increases, the variance approaches 1. Let's have an example. So degrees of freedom is equal to 20. Let's compute for the variance. So here is our formula. Let us substitute 20 for our degrees of freedom. And 20 minus 2 is equal to 18. 20 divided by 18 in lowest term, both divisible by 2, is 10 over 9. And this is equal to 1.11. So now we are in a lesson 2, which is confidence interval. We have learned that statistics have 2 different kinds, the descriptive statistics and inferential statistics. There are 2 ways in making inferences about the population. One is through estimation and another one is hypothesis testing. But our discussion will only focus on estimation, particularly on interval estimation. Let us define first estimation. It is a process whereby we select a random sample from a population and use a sample statistic to estimate a population parameter. So here is the estimation process. First, you need to define your population. And then here, you are going to choose your sample. You are going to subject your sample to statistical test. And whatever you will get from here is what we call a statistic. Remember, statistic is any numerical value that describes the sample we are going to use this statistic. And we all know that the parameter is anything that describes the population. Let us start with point estimation. It is a single numerical value obtained from a random sample used to estimate the corresponding population parameter. A graphical representation of this is this one. So this is the point estimate. It is just a single numerical value. Here are most common point estimators. Sample mean X bar is the best point estimate for the population mean mu. Sample standard deviation, small letter s, is the best estimate for the population standard deviation, sigma. And sample proportion, p hat, is the best estimate for the population proportion, capital P. Let's have an example. A random sample of 35 grade 11 students in St. John Integrated High School were selected. Their mean height in cm are as follows. Find the point estimate of the mean height of all grade 11 students in the school. To solve for the point estimate of the population, all we have to do is to add all this height of 35 samples. And then, we are going to divide it because we are looking for the average. And the answer here is 153.89 is the point estimate for the population mean height of all grade 11 students in St. John Integrated School. Now, let us have interval estimation. It consists of two numerical values defining an interval within which lies the unknown parameter we want to estimate with a specified degree of confidence. Here is a pictorial representation of interval estimation. Here are the two numerical values defining the interval. The values depend on the confidence level, which is equal to 1 minus alpha. Alpha is a probability of error. The interval estimate may be expressed as estimator plus minus reliability coefficient times standard error. So you've seen here confidence level. Let us define it. Confidence level, the likelihood expressed as a percentage or a decimal that the interval estimate contains the population parameter. Let us have this figure. So this portion here is what we call the confidence level. And this is denoted by 1 minus alpha. 1 minus alpha is the area beneath the normal curve between the critical values. So, this means these two values here denoted by negative z and positive z because they are standard scores or z-scores are critical values. And this portion here is the alpha. Alpha is the remaining area in the tails. Now, alpha is the probability of error. So, the confidence level 1 minus alpha, 1 is the total area of the curve. Subtracting the probability of error, then you have the confidence level. If these two sides here is alpha, then each side is alpha over 2. Simply because alpha divided by 2 is alpha over 2. So let us talk more about confidence interval. Confidence interval, also known as the interval estimate. It is a range of values that is used to estimate a parameter. The estimation may or may not contain the true value of the parameter. It has lower limit and upper limit that serve as a boundary of the estimate. It is written as mu is less than the upper limit but greater than lower limit, or open parenthesis lower limit, comma, upper limit, close parenthesis. To solve for the lower and upper limit, we have this formula. So, lower limit is equal to the sample mean minus from the margin of error. And for upper limit, we have the sample mean plus the margin of error. So again, x bar is the sample mean and capital E here is the margin of error. So what is margin of error? Margin of error. It is a range of values below and above the given statistic. Here is the formula. So z sub alpha over 2 is a critical value or confidence coefficient. Sigma is the population standard deviation and n is the sample size. Let's have our first example. The time spent in playing Dota of 125 teenagers in your barangay range from 30 minutes to 1.5 hours at 99% confidence level. Let us determine the following. Let's have the first one sample size. So we have here 125 teenagers. Lower limit is 30 minutes. The upper limit is 1.5 hours or in minutes, 90 minutes. Confidence interval mu is less than 90 but greater than 30. Or we can also write it this way. 30, 90 and closed by parentheses. To solve for average playing time, we just have to add 30 and 90 and then divided by 2. 30 plus 90 is 120. 120 divided by 2 is 60 minutes. For the margin of error, we have 60 minus 30, that will give us 30, or the upper limit 90, the average playing time 60 is also equal to 30.